Why not counterfeit stereo equipment? Well, that's an interesting question from Josh right here in good old Boulder, Colorado. And Josh writes, "Hey Paul, what are your thoughts on counterfeiting high-end audio components? For example, if I were an unscrupulous manufacturer, what would prevent me from buying, say, one of your products, popping the hood, changing a couple of things around, and repackaging your design into my own box and logo? I think it'd be easier to rip off the design of a component like an amp rather than something more visually obvious like a loudspeaker. But if outright copying doesn't take place in high-end audio, how about borrowing competitors' designs? How do you feel about that?" Well, thanks, Josh. How do I feel about that? Well, I guess I can't. I understand. I know that there are a lot of things ripped off today. In consumer audio, all sorts of things are ripped off. Some guy comes out with a great new product, and pretty soon they're being copied, from overseas, from even here domestically. It happens all the time. So I guess, what is it? It's a form of flattery, copying. I can't remember the exact phrase, but yeah, I mean, that happens. It's nothing that would interest us because we have a very different approach. We're not looking to make the same thing that somebody else is. That doesn't make any sense. Even if I could copy what this guy over here does or that guy over there does, he already makes one. I mean, I don't understand why we would even be interested in doing such a thing. Our interest is in building products that we want to own, and I hope our customers will like them too. But more to the point, to the particular question, because I think it's in general. I think Josh is asking in general why more of that isn't done. And I think the answer there's a several-fold answer. If I just take this board, which is a digital input board for a direct stream DAC, and I apologize to the Ohm's law listeners because you can't see this, but it's just a small board. I'm going to guess this thing is 10 inches by maybe 6, maybe 10 by 6, got some connectors on it, and you can see there's a bunch of parts. Well, there's probably 100 parts on this thing. And while somebody, and in the middle of it is this large FPGA, and this is a little unfair because this field programmable gate array has code on it that is proprietary to the company, has taken Ted Smith, decades to design, and you really can't steal that because it's locked inside. But even if you could, copying all this, trying to get into this board, which has about 4 layers inside of it, would be a monumental task. These boards today are so complicated with so many tiny parts and traces and ground planes running all over the place that, yeah, the guys at NASA and the spooks at NSA, I'm sure they could take it apart if they wanted to, but it's not that big of a secret. The products that we make are original in their design, as most of our competitors are, but at the end of the day, they're not totally original. They are based on classic, tried and true designs that we borrow from others who have started way before us, and others still that have come up with a good idea. I'll give you some examples. Take the current source. So a current source is a constant current source, it's better known as, is basically 2 transistors, and you can do it with a couple of diodes and a transistor. And essentially what it does is it makes sure that within an amplification stage, there is a constant amount of current regardless of the amount of signal. So if you just use a resistor to set the current in an amplifier stage, then as the signal gets larger, the current goes up, and smaller and the current goes down. So you have this, the current is going up and down with the signal. You can get a much more linear amplification chain by using a constant current source. And this ensures that the current, regardless of the signal, is always the same. And you can adjust it, 3 milliamps, 5 milliamps, whatever you want, you can adjust it. Now that circuit, that constant current circuit, was invented back in the 70s by a genius guy named Bob Widlar. And I've talked about Bob before. He's the crazy man of Silicon Valley. I mean, this guy was wild, and he invented the first op-amp that PS Audio used, the 709C. He invented essentially the integrated circuit for use in analog. He made some of the very first analog circuits. But so that's just an example of what we would call prior art, or a complementary output pair, or a JFET, or a tube input stage. We're all borrowing from each other. We all read the same textbooks, and we open it up, and here's a classic way to do it. Great. You hook it up, and you go, well, that doesn't sound exactly the way I want, and it doesn't solve exactly the problem that I am particularly interested in. So I start with that design as a basis, and then I'm going to start adding things to it. Maybe the design I start with is a classic vacuum tube input stage, but now I want to be able to drive long cables, and I want to be able to have, slam and punch in the bass. Well, to do that, I'm going to need to make sure that high impedance input and output vacuum tube stage has a really robust and kick-ass current stage on the output, an emitter follower or some type of buffer on the output to drive those long cables without bothering this. That's not something that particular circuit is not something that's written up in the textbooks. They talk about it, but the way that we implement it using MOSFETs is kind of particular to PS Audio. But that's just one of many variations that we do, borrowing from everybody. So I guess the short answer is I don't think most people in high-end audio are actually interested in counterfeiting the work that we do, because A, the markets are rather limited, so it's not like trying to rip off an iPhone or something that sells in the millions. So maybe the answer is it's just not worth people's time. I don't know, but it's not something that we're interested in. But a good question, and I do appreciate you asking it, Josh. And if you're in the area, come on by. Take a look at the new building. We're here. All right.